something a little bit different that builds upon. This is actually an Algebra 1 topic, inequalities, which some of you might know a little bit about already. So the first problem, let's think about, the hard drive on your computer has a capacity of 120 gigabytes. You have used 85 gigabytes. If you want to save some home videos to your hard drive, what are the possible sizes of the home video collection that you can save? So what are possible sizes? What do you think? Just give me a number.
How big is your video files, big? You've already used 85. You have 120 total. What could they be? 35 gigabytes. 35.
All right, 35. Anyone think of any other number?
What if I just don't have that many videos?
What if you just want to like upload one video?
What would work? Those of you have phones and you know you use up all your space. It's about, what if I had like one movie? I want to put like one movie up. How much space would that be? For those of you who take little videos. What numbers would work? 7?
7, all right, that one.
Do I have enough space in my hard drive for 7 more gigabytes? What other numbers?
5. All right. Anyone else think of any other numbers? 15. Okay. So what do you notice about these numbers?
How do you know that they're all options?
Because they're all less than 35,
They're all just less than 35?
or that 35 is equal to 35.
Less than or equal to 35. So we remember, I know you've seen these before. You remember all these symbols?
What are those symbols? Who knows what they are?
Where are these?
Greater than, less than, equal to, or greater than, equal to, or less than.
Okay. So this one's like less than or equal to, greater than or equal to. Okay, so that's what we're going to be working with today. Alright, so let's continue with this problem. How can we set up an inequality to solve this problem? And how do you know which inequality symbol to use?
And this is the tricky part, because when you have a real world scenario, which let's be honest, most real world scenarios are inequalities, right? They're not really equations. You're going to deal with inequalities more, probably. 6 Flags, anybody? 6
Yeah.
Flags, right? To get on a ride, how tall do you have to be? What? What height for your favorite ride? 56 inches? I heard like 56 inches. So does that mean that only a 56-inch tall person could go on the ride? How tall could you be to ride the ride? You could be 57 inches. You could be like 6 feet tall. You might be like 5'9". There's a range, right? And that range is an inequality. So the confusion is typically what inequality symbol. Look at this scenario. What inequality symbol do we want to use here? If we know we have 120 gigabytes total capacity, 85 have been used. The amount remaining, what does that have to be? Think about the symbol when we set it up. Our total is going to be what?
It has to be less than or equal to 35.
Well, the total. So the unknown including the 85.
Well, let's take a look here. So what do we know? What do we know? From this problem, what do we know? Already.
That your capacity is 120 gigabytes.
Okay, the hard drive capacity, we know it's 120 gigabytes. What else do we know? What? Yep, we've used 85.
And think about, as you're thinking about the numbers that we know, why did we set it up this way? What is that? Look at that scenario, just like the boxes where we're starting to create our inequality. Right? The current hard drive space used, that 85, plus the size of our videos, whatever it is, needs to be at the most 120 gigabytes. Right? You just took a sentence, just a statement, and you translated, we're translating it right now to a mathematical inequality. Right? That's a skill that we will continue to drive home, because that's the hardest part about applying math to real life.
So we know plus, and then we just said we're not sure what the size of the video is, right? So what
What do we do if we don't know? If that's our unknown? That's our variable, good.
Yep, that's a variable. So we use V for videos, and then is at most. So what can we put there for is at most?
What do we know about the hard drive space that we've used and the videos? That number compared to that 120, what does that total on the left have to be? Less or equal, good. Perfect. So we constructed it. Great job. We just did
So
that.
we just did this. We just filled that in. Okay, so now let's try and solve it. What would you do? What's the first thing you would do to solve that? All right, how about this? What would you do if this is what it looks like? What's the first thing you would do to solve this?
Subtract 85 from both sides.
Subtract 85, okay. So what do you think the first thing you would do to solve that would be? Good, the same thing, subtract 85. So you solve it the same way as you would solve an equation. So now we have V is less than or equal to 35. Great. So if you notice so far, we solve it the same way. There are going to be some differences between inequalities and equations that we're going to see. So what about this? What would you do here? How would you solve this?
We're still isolating the variable. So we still have to identify what operation is happening to our variable and how can we undo that. What operation is happening to x? We're dividing it by 3. So how can I undo the division of 3?
The inverse operation. So we multiply this side by 3, and because we multiply this side of the inequality by 3, we have to do the other side. So now what do we have? X is less than negative 6. Good. So we just solved an inequality. Okay, so what's different between this inequality and the one we just worked with on the last slide? What's different? The other one was x divided by 3 is less than negative 2. What's different? What do you notice that's different between this inequality and this inequality?
So far we found a lot of similarities between solving equations and solving inequalities. Right? They're not identical though. There are some differences. Now we're going to explore some of the differences. And you've solved inequalities before, so this is a little bit more of a reintroduction. And what do we identify in that inequality? Negative 3y is less than or equal to 9. Think about the differences between inequalities and equations that you know. Well, why don't we just solve it? All right, let's solve it, and maybe we'll figure out an error.
Okay, so
Or something
how do we
different.
go about solving this? Well, let's first think, what numbers can you substitute for y that would make this true? Let's think of like a couple numbers. Anyone think of one? Yeah. 1. All right, so let's look at a number. Okay, so 1. Is there any other? 0 works because negative 3 times 0 is 0, and that is less than or equal to 9. Anyone have another number that would work?
Your hand. 2.
2. All right, so that's
Wait, are you saying,
negative
did you say
3 times
negative 2?
2.
Positive 2? He said positive 2.
Oh, where am I going? I'm going backwards, sorry. So you said 1. Sorry, guys. That's a 1. All right, anyone else? 3. All right,
Negative 1. Does negative 1 work? Yeah. 2.
-2, that works.
About -3.
What about -4?
So why don't we shade in black the actual graph here? We know our limit is -3. And we've already identified that
So we
-2, -1, 0, 1. So that to the right side is our solution.
So we know -3 works. That's why I'm shading that as a big circle because that's equal to this. And then we can just shade this way. Alright, so now let's try, so that just shows us right now. That's what we know will work.
That is our solution set in a graph. But if we were to solve the inequality, what would we do to get y isolated?
I divide by -3. So then what do we have here?
Because we're going to see something that's just not what we need.
Y is less than or equal to -3. Is that what our graph is telling us? Is that the same thing that our graph is telling
Does
us?
that show that the value for y is going to be less than or equal to -3? What does our graph show us? So y is actually, top of the graph. We have the answer. The graph is right. So our values of y are what compared to -3? Are they greater or less? Look at the graph. Is 0 greater or less than -3? Greater. So our solution set is greater or equal to -3. So what's the problem with the solution that we came up with? For those of you that have learned about inequalities before, what must we do when we multiply or divide by a negative? What did we not yet do in our solution?
So this graph is telling us that y is greater than or equal to -3. This is saying that y is less than or equal to -3. What do we need to change?
When we multiply or divide away our variable, what must we do? This is not the first time you're seeing this, so I know you need to go back. So go back to 7th grade in your minds, pull this out. We know you focus a lot on equations, but this is not new here. We know that you've learned this. We just have to pull it out because you just haven't done it in a long time.
You have to switch it around.
Say it. Be more smooth.
You have to flip the sign.
The sign. We need to reverse this sign. Because that's what's going to make this true. I'm actually going to show you in another way to help you understand a little bit better why we need to do that. So I'm going to show you, I like red. I'm going to show you 3. Okay, 3 is greater than 2. Is that a true statement? Is 3 greater than 2? Yes, that's true. Okay. So what if I multiply by -2 over here? Well, first of all, I multiply by -2 over there. What do I have to do? On the other side, it's the same as an equation. You still have to, whatever you do on one side of the inequality, you have to do on the other. So I just multiply by -2 over here, and now I'm multiplying by -2 over here. So what do we have? -6 is greater than -4. Is that a true statement? Is -6 greater than -4? No. Alright, so that's why we need to change the sign every time you multiply or divide by a negative number. Okay, so what if we went ahead and divided now? Now I want to divide by -1. I'm doing it over here, so now I have to do it on the other side. So now what do we have? -6 divided by -1. 6. 6 is less than, what's -4 divided by -1? 4. Is that a true statement? No. So do you see why we need to change the sign and reverse it when dividing or multiplying by a negative number? Do you understand that?
Whether you use that type of example, which that example does not have variables. For those of you that need something straightforward, that is an example that you can use to remind yourself. Right? But when you're solving an equation, you're going to have a variable. So you may not realize that you made the mistake. Oh, instead of x is less than 7, it's supposed to be, I should have changed it to x is greater than 7. When in doubt, you can use the graph to substitute values in and check. Just like we would check an equation by substituting our value back in, by using that graph, that solution set, you can check it. You will catch any type of mistake if that's an error that you make. When we learned this, we were very simply told, when you multiply or divide by a negative, you just switch the sign. That's how we were taught. A little different now. We want you to understand that there's an actual change to your solution set when you multiply or divide by a negative. Okay? But those are ways that you can check. And again, we always need to self-check when we're doing this type of work.
So if you want to write, if there's anything that you need to write down in this class right now, this is what is most important that we reviewed today, that we talked about today.
The key difference in solving an equation and inequality is this. And again, when you learn this for the first time, this is what a lot of students struggle with because it's very different. It's just different than solving an equation, which you spend most of your time doing.
So when multiplying or dividing both sides by a negative number, the inequality symbol reverses. That is important. I can't stress it enough. That is important. Okay? So I'm going to give you a couple minutes to write that down.
Once you have that written, let's take out a sheet of paper for your DOL, and then we're going to use lots of time to practice solving our inequalities.
And at this point, I want you to use your self-assessment cards that I had you take out earlier. I just want to see how everyone's doing.
So red is I am so lost, so stuck. Yellow is I'm kind of getting it. Green is I got it. And blue is I really understand inequalities. I can help somebody else if someone needed help. When you finish writing down your note, just show us where you're at so that we can gauge where to stop while we're helping throughout the room. You can leave them on your desk. You don't have to hold them up.
And then this is going to be your DOL for the day. So I'll give you like 2 minutes to do that.
Before we start that, let's explain to them what we're doing after. Because some of them are going to finish quickly.
Okay, so, alright, so before we start that, sorry, I'm going to explain. So some of you who have, so after this, after the DOL, which we're going to go back to in a second, I'll go back to that so you can see it. But after the DOL, there's must do, may do options here. If you have a red, I see a few of you that have red
Or yellow.
Or yellow, you want to really work on this must do. This is reviewing everything that we did in class today. It's giving you some extra practice to make sure you can really master it and turn your assessment card to like a blue or a green. Okay, so that's going to help you a lot because we don't have a lot of time. We only have a few days to work on this.
Remember, we're doing 8th grade and 9th grade in the same year. You're learning 2 full grade levels. So that's why we have to accelerate, but we're here to help you along.
And then if those of you who have like blues and greens right now, you can go ahead and work on Galactic Hero, but make sure you're only choosing learning targets 4 and 5. That's what we're doing now. So those are the assignments you want to choose over there. Okay?
So when you're done with your DOL, which we'll put up, this is where you'll go. Okay, you choose what to do. The textbooks are under your desk. That's the Algebra 1 textbook. You will not see inequalities in the workbooks because inequalities are not taught in 8th grade. It's an Algebra 1 concept, so that's why we have to use the other book when we're working with the Algebra 1 materials.
All right, so I'm going to go ahead and put the screen back to your DOL. So I'll give you a few minutes to work on that. Well, you can really take as long as you need. And then when you're finished with the DOL, put it in the DOL bin, and then I'll switch this page so you can see, okay? So it just says, how are you solving inequalities, or how are solving inequalities and solving equations similar, and how are they different? So just write in like a sentence or two, like how are they similar and how are they different? What did we go over today? All right? Yes.
Identify the differences, and then I'll summarize the differences, and we'll be able to
Solve and solve. What are the steps you take to solve an equation? How is it similar and how is it different?
try to state some differences and then hold them to the rule of the
I'm just gonna turn to the next page here, so those who are finishing up the DOL can see what page numbers you can go to, okay? The DOL is also written over here.
Learning the first one is learning target 2, the second one is learning target 1. The 2 questions.
You're not using your workbook because that doesn't have any algebra stuff.
So we're
in it.
using
Yeah, so your
Text is under your
textbook.
desk.
Okay.
We're gonna go over a couple
Because none of this inequality, none of the inequalities are gonna be in your workbook. That's an 8th grade workbook.
No, stand with everybody. Over here. Joanna, when you're done, come on over. Isidro, when you're done, come over here, okay? We're gonna go over all these. Alright. I just wanna help clarify. Okay? It's easier to just bring you guys together. So when we solve inequality, it's almost the same thing as solving the equation, right? And it is, like every example, until your multipliers by right. Okay? So in this scenario, how do we get C by itself? Subtract one. Well, C is here. What's happening? It's C. I'm going to subtract the 9. I'm going to do that to both sides, right? Because now when we talk about doing the same thing to both sides in an equation, same idea, but in an inequality, it's because the relationship will still be true if I do the same thing to both sides. So I have -7 is less than 6. So I'm done here, right? I already isolated my variable by itself. So that's like adding or subtracting.
Yeah.
Here, what's happening to n? We're adding 3. So what we're doing is by itself.
Yeah.
I'm going to subtract it because I'm still just adding 3. Now this one is going to be a fraction. If I have a third and I take away together,
That was gonna help you, but I need
-2. So now we're going to get into other operations. Okay, now this one is just a third minus 3 wholes, so that's 6 thirds is negative. It's 9 thirds, sorry, so 1 minus 9 is negative. Yeah, that's other operations. Instead of just addition and subtraction. Here, what's happening to Alex? It's being divided by 5, so we'll try to do another multiply. So I'm going to multiply both sides here by 5. And this is a big one. So this, again, it's just like an equation, except I have negative 2. This last one is the different one. Okay, so these 4, so far, you saw that the same way you do an equation. So it's the same. This is where it gets a little different because when I solve, I'm dividing here when I get C by itself, so divided by negative. So anytime, I know it's weird to just think of that, but I always wish you like because we were just told divide and multiply by negative, just switch the sign, period. Like we didn't even ask questions. So to get C by itself. What am I doing?
Shelly, don't bring up a
Why subtraction?
Are you gonna
What operation is this between C and 5? If the C and the 5 are touching, what's the operation? It's multiplication. If it was addition, it would be this. You know, a lot of us think that that's addition. It's not. If the numbers are multiplication, that addition sign would have to be this. Okay. So this is multiplication. How do I do that? I divide by -5. So here's where
Yeah, but you have these
I divided by negative. So it would be 6 C, and this changes.
There's a website.
So I do my math, it changes it. Now why does this work? We're gonna figure out why this works. If I solve it, this says that my variable for C can be any number that's bigger than 6. Which is 6. So 6,
I want you
7,
to
8. And then we'll try 5. We're gonna try one on both sides.
option 10. I want you to try and do
If I substitute in a 5. Negative 5 times 5 is what? Negative 25. Is negative 30 a bigger number than negative 25? No, it's smaller. Negative 30 is like harder. So that doesn't work. So I know it's not that size. Let's try 8. Negative 5 times 8 is what? Negative 40. Is negative 30 bigger than negative 40? Yes. Which means this entire side has to be like this. So C has to be greater than 6.
I'm gonna make the first step.
So that's why my answer is
Yeah.
I don't want to sit there. Oh, it's probably
or you could say C is greater than 6. That's why we switch the sign, right? So this was what we substituted. When we calculate it, divide by negative 5. It's negative 6. This changes 6. So C is greater than 6.
Yeah, that one was easy, but like.
Okay, so if you're looking for more, if you feel very confident, I thought I was correct, like if you wanted to divide it, 81, probably 7 to 23, so
C is greater. So C is greater than 6 or C is greater than 3. Sorry. The thing is, if you do the number, and you're not really sure of this number, you can just choose a number on each side and test it. Whichever, if this doesn't work, but this one does, it's this whole side. And then you can say, well, my variable is greater than 6.
For 1 second, for those of you who are doing the must do, these
In the textbook, page
work
175,
right here, the
addition
page
and subtraction,
181,
like these two.
723, those are more of the
And then
multiplying
page
divided by
181 is
negative
the
numbers practice.
multiplying and
So if you
dividing.
start
And
right
so
here,
start with
you're finding that these ones are like way too easy for you
And
on
these are
page
the page
175, then you can just skip that and go to
When you multiply
page
divide is when it may
Okay.
get, like, you may have to start switching the symbol. Start with practice, and we're gonna come around to see how you're doing. Okay? A little bit better, a little bit more clear. This is where it gets confusing, but I promise you, it's one of those things where once you know it, you'll always use it.
It's like, I understand the impact.
You guys can do a gravity test.
She said, change the sign every time you multiply or divide by a which number. So that's how we
That's it.
change the sign every time you multiply or divide.
So for these, it's the same thing. Two equals the only difference is answering by the last test. Would you like for that one, they would do the same answer. So equals is only one. The inequalities is so that's what changes here. And then, like, again, this is the most complicated solve equation. And then this is the one where we'll
When do inequalities so like n has to be a number of negatives. So any number.
There you go.
Negative 2 minus 6. Negative 2 minus 6 is negative.
They did it in like, they're supposed to be 7, but unfortunately it's 7 people this occupation. So while they were supposed to be different, this is pretty much the same. Oh yeah, it's definitely our curriculums. Like mine, I would say like the prerequisite skills part actually. Because like that's, unfortunately that's, we find that a lot.
Okay, then 35. What are you talking about? Negative 8. Have a good debate. Exactly. You can change it so if you want. Boom, I get it. Trauma. Yeah, negative 45. Negative 35. I mean, number 35, I don't understand. And then this thing with the 2 minus 9 is what? Negative 7. So you have negative 7 is less than C. Wait, sir, -1 is everything greater than or equal to. So basically we can add two, right? You don't need eggs. No.
This actually shows you like how to and then how to I wanted to try to
I was thinking of doing it. I was gonna do that, but I caught myself. I was just like, wait, where's the word? Let me write it.
Oh yeah.
So when you multiply people, yeah, because I was told about the
Oh, you guys didn't even know that yet. Look, you subtract 5 from both sides, but -1 is -6. It's greater than it's greater than.
Jump to page 181. Okay, so no, you know what? If you feel good about it, like most people are kind of like that.
You add 1/4 on both sides. But right, well, listen. So, do you
No.
Okay, you have the problem written down. So then, you subtract 1/4 from both sides, right? Yeah. And then, look, use the she's there, right? And then you get 2/4. Yep. No, because it's negative. Yeah. So you negative, and then take it back. Subtracting negative. -3 plus -1. No, yes, of course. So that. So then that means 8 is greater than or equal to. Yeah. Boom. Yeah. No, because I got it. Right.
Wait, I got my doing there.
Okay. Wait, we like fractions and then they like.
I thought you just had five that you hated fractions.
No.
I hate decimal, but I like it. 8.6 plus 8 equals 14. What's 4 minus 6 is 2. Okay, that's wrong. 14 minus 8 plus 1 minus 8 is negative. I got negative 7.2. Negative 7.2. So,
I got more than
14 minus 8, right? And it'll be like
Wait.
I got 4.5.
I got B is less than negative.
I got Z is less.
5.4. Because look, right there. No, it's not negative. It's 5.6. I am
It's 5, yeah.
exactly. That's what I did.
So you have 4.5, right? And you're taking away
So Z is less than 5.4. So Z can be 5.3. Wait, so 0 minus 6 is going to be, no, this turns into a 10. Sorry, look, I'm going to show you. I get it. See, I'm going to show you. See, look. Jamie, look. I keep trying to help you.
Try to be 20.
So it's 1/3. Look, 1/3 is less than n plus 3. So you're gonna subtract. No, I don't. So wait. So what's 1/3 minus 3? Negative 2 is less than n. Negative 2 is 4. Well, you can actually take it wrong. No, you're wrong. But we need space to write.
I like these. I want you to try these.
See,
I have to make some.
That's negative. Look, I will show you. Renee, look. 1/3 minus 3
Why is it the answer?
equals 2 and 2/3. Because look, if you take negative 2 and 2/3, and you add 1/3. You subtract. Exactly. It's 1/3 minus 3, not 1/3 plus minus 3.
You just said so.
Wait, no. 1/3 minus 3. That's
According to my
No, it's not. Look, Jamie. So listen. That's the answer. Listen to her. Look, 1/3 minus 3/3. It's not. because 3 equals 9 over 3. Stop talking. Jimmy, simplify 9 over 3. Exactly. It's the same thing. So here, what you have. Time is 9 over 3.
What's the answer?
No, but I think you said it before, bro. I always
Yeah.
Oh yeah, the one I like.
You're like you're saying, should I multiply n to right? 5 over 5 is 1. But you don't want to multiply by 1.
He said algebraic.
It has to be 5 over 5 or 5 over 3. You said 5 would multiply by 5.
Subtract 4 from the side. And then what do you get? 3. I wrote B. I wrote B. Jimmy, okay, it doesn't matter. Yeah, 3.8 minus 4.
So if you wanted to graph it or like try values that work, say what's an let's go with 0, right? Because I like 0. If I substitute 0 here, is 0 bigger or greater than negative 2? Why do you start with number 2?
Alright, I think I'm fine.
19 and then 20 and then I think what operation is that?
She's a girl. He just
So if you have the right idea, we're just gonna look at in about 3 minutes, we're gonna wrap it up before you're dismissed. So keep your eye on the time.
Miss Caravano, I have a really big question.
There you go.
3.8 minus 4.
I don't know. Is it?
No, it's not. It's negative.
If I have $3.80 and I owe you $4, how much money do I have?
That's $3.80.
And then I'm gonna pay you $4. How much do I have?
How much do I owe?
How much do I still owe you? That's it first.
I picked it like
Good. So it's negative 0.2.
oh, 0.
We only have to do really good.
Like that little blue that was there.
So for his scenario, all you have to divide by
What's wrong with you? Why are you earning? Dude, you're burning out.
Alright, excuse the interruption, it is that time of day. We have a few announcements. Please, heads up, all students participating in the Aspire High program. We are excited to announce the first meeting is taking place this Friday, October 7th. Please report to the library at 2 o'clock and be punctual. The meeting is going to take place on Wednesdays and Fridays from 2 to 3, and late buses are available for transportation after the program. Any questions? Please see Mr. Gant in guidance tomorrow. We look forward to seeing everybody on Friday. That's the Aspire High. Boys and girls cross-country team will meet in the gym today after school for practice. Again, boys and girls cross-country will meet in the gym today after school for practice. Anyone ordering a Pioneer Nation shirt supporting the cheerleaders, your order is due Friday, October 7th. Thank you for your support if you did order. At this time, we need all of our van riders to make their way to the back. Our van riders